Construction technologies are constantly evolving. We will show you solar paint that can power an entire house, Chameleon Bricks that change color, and a swarm of robot builders. But watch until the end. There's an incredible technology, a machine that can build massive bridges in just a few days. Chameleon Bricks. Chameleon bricks are also known as velvet or velour bricks because of their beautiful color. This effect is achieved not through some incredible chemical components or the use of complex technologies, but rather through cleverness and an understanding of physics. The uniqueness of this building material lies in the long, thin grooves applied to the surface of the clinker using metal brushes. These strips refract sunlight, and at different times of the day, the facade of the house changes its color, from light pink to dark burgundy. When clinker is used for interior decoration, it also changes its color, but this time thanks to artificial light. The material doesn't fade like regular bricks. If the workers have done everything correctly, there won't be any discoloration at all. In addition, unlike classic bricks, velour bricks are resistant to salt and water damage. If this technology doesn't seem groundbreaking to you, the next one will surely leave you amazed as we continue to raise the stakes. Pneumatic Foundation. This technology is the brainchild of the Japanese company Aerogel Systems. They have developed a system that makes a building appear to float in the air. This happens because there is a certain air cushion, and as soon as a preset sensor is triggered, the building is suspended above the ground. This isn't done for aesthetics, it's due to demand in specific parts of our world. The foundation is not connected to the structure, and the lift can occur at any moment upon signal. Therefore, if another earthquake is imminent, for example in Japan, homes equipped with this system should remain unscathed. When seismic sensors signal, they activate and start pumping air into the cushion, which elevates the building. The building hovers about 4 to 5 centimeters above the ground, which is sufficient to withstand a fairly significant earthquake. In Japan, several dozen homes are already equipped with this technology. According to forecasts, this innovation will soon spread to many earthquake-prone countries. Quite technologically advanced. And the next development is a lifesaver for private houses, parking lots and public spaces. Now, asphalt is no longer necessary. EconoGrid 40. This technology provides a porous reinforced surface capable of withstanding frequent pedestrian and vehicular traffic, including heavy vehicles. A real alternative to concrete and asphalt, EconoGrid 40 is suitable for lawns and gravel areas alike. The 40mm deep tile cells protect grass roots from damage, and the cell structure with recesses allows grass roots to grow unhindered from one cell to another, resulting in a stronger and denser grass cover. As a result, you get not concrete jungles, but a genuinely green environment. Lightweight, environmentally friendly, EconoGrid 40 with a unique locking mechanism on each tile is easy to install, saving time and effort. Regarding reliability, each square meter can withstand a pressure load of 150 tons. But cell tiles are just the beginning. The next technology is a real step into the future, where machines will do the building for us. Project Termis. In the search for innovative construction methods, Harvard researchers turned to nature for inspiration, particularly to termites. After all, termites can build large structures without central control. They simply carry a piece of mud to the site of the first construction area. If it's occupied, they carry it to the next site. Project Termis employs the same idea of swarm construction, but uses small robots. These simple, inexpensive drones construct structures according to the initial design, placing blocks in the first available space until the structure is complete. The swarm doesn't require human intervention after the initial task is set. This system is perfect for constructing structures in hazardous locations, in space or underwater. The swarm could also perform labor-intensive tasks, saving people time. And the next construction invention is already in common use and can be purchased by anyone. BUMPA electric load lift. This is the original product from BUMPA Mace Industries that revolutionized the roofing industry and gained popularity in the UK and increasingly on an international level. The BUMPA assembles quickly and unloads easily from a truck. It can be put to work in just 4 minutes. It can lift more than 1,000 tiles onto any roof in less than 25 minutes. The BUMPA not only unloads but also has a reverse drive, allowing it to assist in the removal of the roofing material by lowering it directly onto the vehicle from the lift. The device is straightforward to use. You unfold the machine, connect it, and that's it. It can even operate from a portable 5 kW generator. Titan brick. The US-based company Titan Brick, in collaboration with the University of Florida, has developed a brick that is made up of 90% waste and leftovers, with the remaining 10% being a patented formula that the company doesn't disclose. According to the manufacturer, using this material can reduce home insulation costs by 50%. Furthermore, the new brick is 2.5 times stronger than concrete blocks and can withstand heating up to 980 degrees Celsius. Despite its unique composition, the brick is resistant to mold, fungi, and is waterproof. Buildings constructed with it can withstand hurricane-force winds. Interestingly, the manufacturing process of Titan Brick doesn't involve firing in a kiln, thus requiring significantly less energy for production. To ensure easy and durable masonry, the products have tongue and groove connectors on both sides and are fixed not with traditional mortar but with a special non-toxic adhesive. One of the main advantages of Titan Brick is that it can be produced directly on the construction site, saving on transportation and allowing you to control the quantity. Solar paint. Specialists from the University of Notre Dame have created a unique paint that can generate electricity when exposed to sunlight. However, the paint must be applied only to a conductive surface, which is not a significant issue since almost any building material can be coated with metal, and the thickness of the metal coating can be very thin. Developers hope that their project will be used by car manufacturers as well as building designers. The paint created by scientists contains nanoparticles of titanium dioxide, which are coated with either silicon selenide or cadmium sulfide. In either case, according to scientists, the cost of producing the paint is relatively low. However, the efficiency of such a photovoltaic element is modest, slightly over 1%. But if you imagine that an entire roof and walls of a building become a solar panel, even this 1% becomes a reasonable figure. And the next technology looks very surreal, especially when captured in action. Road printers. Laying roads takes a lot of time. It's hard work involving hundreds of people and dozens of expensive construction vehicles. On average, one worker can lay 100 square meters a day using traditional paving methods. Road printers like the Tiger Stone can reduce this process, printing up to 300 square meters of cobblestone pavement a day. Another road printer RPS can lay up to 500 square meters a day. 1 to 3 operators feed the machine with bricks. Then a pusher sorts the bricks into a pattern like a carpet. At this point, gravity takes over, and the machine lays the brick road. A roller similar to a steamroller presses the bricks into place. These printers operate on electricity and have few moving parts, making them easy to use and maintain. Moreover, they produce minimal noise, especially compared to traditional road paving methods. Of course, the main difference between most roads and those laid by these printing machines is that they lay bricks, cobblestones or tiles instead of asphalt. Nevertheless, block roads are even better than asphalt, because they filter water, expand when frozen, and last much longer. Rubber roofing made from tires. One of the new materials is rubber roofing, made from old automobile tires that have been recycled. This material was invented in Europe and is not widely known in the rest of the world yet, but it fully meets all the requirements for modern roofing. This type of roofing excels in its tasks. It gives a building an attractive appearance and provides reliable protection. Due to rubber's ability to compress and stretch, it is exceptionally durable and can withstand temperature fluctuations and mechanical impacts such as hail. Roofs made from rubber roofing have excellent waterproofing properties, do not crumble, resist breakage and cracks, are impervious to the harmful effects of ultraviolet rays, do not rot, and absorb noise well. Unlike metal roofing materials, it doesn't deform or corrode. And the next technology is truly groundbreaking and innovative, the lightest and strongest material that can be used in construction. Aerogel. This is a very hard yet lightweight insulation material. It's often referred to as a frozen smoke. It's derived from a special gel using a patented technology that transforms a liquid material into a gas-like substance with a solid consistency and transparency. The shape of the product is defined by nanotubes present in its composition. This method allows for the production of extremely thin sheets with reliable insulation properties, consisting of 90% air. The potential applications of aerogel sheets are wide-ranging, from making outerwear to insulating buildings. Its insulating capabilities surpass those of fiberglass insulation by a factor of 4. This thermal insulation material is nearly weightless and reasonably priced. In recent years, it has been gaining popularity worldwide. And the next technology is a real lifesaver for old and worn-out buildings, sometimes pushed to their limits. Digital twins. A digital twin is essentially a digital replica of a physical object that contains data about its potential and current assets, strengths, systems, data, as well as various internal processes and resources. Digital twins collect data using sensors to better understand the physical structure of the object and then create a copy of it. Having a duplicate source of the physical structure allows workers to assess and optimize the building. By analyzing the digital twin, they can identify potential efficiency improvements, develop security protocols, reduce risks, and enhance quality. Digital twins allow for testing various scenarios and threats, such as natural disasters, fires, and structural failures, using simulations. This technology is highly versatile and allows tracking the condition of a building almost in real time, with a clear understanding of vulnerabilities in different situations. Window that heats the home. Scientists from Friedrich-Schiller University in Germany have introduced glass that can darken while retaining heat. This development doesn't require an electrical connection, and its effectiveness is comparable to traditional solar thermal systems. This magic glass is achieved by introducing a special liquid containing nanoparticles of ordinary iron into its mass. Depending on the concentration of nanoparticles, the liquid takes on different shades from gray to black. As a result, the glass allows for controlling insolation and collecting solar heat, which can then be used for heating a room. Of course, this can't compare to a classic heater, but if every window in a building has these properties, allowing for heating control and doing so for free, it can be quite sufficient, especially in moderate climates. Now, the next technology is a lifesaver for practically all homeowners. Moisture and mold-resistant plaster. Moisture-absorbing micropore plaster is made from a lime mixture, and it contains about 90% of it with a special microporous structure. It is designed to dry out wet walls of buildings without the need for expensive and complex waterproofing and drainage work. This unique material removes moisture from the base while simultaneously preventing water from entering from the outside. Studies have shown that micropore has an evaporation surface approximately 30 times larger compared to regular solutions, significantly speeding up the moisture removal process. It contains biological additives that, in combination with lime, prevent dissolved salts from leaching out of the brickwork. This eliminates the risk of salt crystallization and the deterioration of the plaster and paint layers. Thanks to this formula, mold cannot settle on the treated surface. And finally, the most spectacular construction assistant that effortlessly ties together massive bridges from thick reinforcement bars. TyBot Robot. This enormous robot assists in the construction of automotive and railway bridges, replacing the work of hundreds of people. Moreover, it is quite autonomous, capable of observing everything happening on the construction site, including obstacles and people. While it focuses on reinforcing steel, other technological processes can continue without interruption. TyBot performs a repetitive and strenuous task of tying rebar, allowing the human workforce to concentrate on more complex tasks. The robot can be operated remotely, so while the crew sleeps, it can already start its work. The machine autonomously identifies its location, positions itself, and ties up to 1,100 intersections per hour, day or night, in rain or shine, all while improving safety at the work site. The robot is available for rent or direct purchase, with terms that can be negotiated depending on the job, and its purchase price is $796,000. There are many technologies, and they are constantly evolving. Soon we will be very close to the point where humans simply choose and designate the location, while smart machines using intelligent technologies do all the work. Thank you for watching.